This question asks, which of the following statements is false? So up here we have an equilibrium. We have molecules A and B going to molecule C and D, or the reverse, molecule C and D going to molecules A and B. And we have to figure out, to answer this question, does the equilibrium lie to the left or does it lie to the right? So the key for determining which direction the equilibrium lies is to find the strongest acid and the strongest base. The strongest acid and the strongest base will always be on the same side of the equilibrium together, and they're going to react. The more stable base and the weaker acid, or also the weaker base, are going to be on the same side as well. So we can either use the quantitative method using pKa values to solve this question, or we can use our acronym CARIO to solve this question. So I'm going to take both approaches. If we consider pKa's, so method number one is going to be that quantitative method. You just have to know basically which molecule is the acid on each side. And sometimes that can be a little bit tricky. In this case, it's more straightforward because we have a charged, a negatively charged molecule and a neutral molecule. Generally, if you have a negatively charged molecule with a neutral molecule, the negatively charged molecule is the base. So we can kind of narrow down the base on each side and then the acid on each side. And this question is a little bit hard because this is an acid that's not a very strong acid. We have a ketone, and those protons on the alpha carbon are going to be acidic. The reason why they're acidic is because when we look at the anion, we have resonance. So that resonance contributor that we can draw is really the key to why molecule A can act as a base. So if we're thinking about pKa values, molecule A has a pKa of about 20. And the acid on the right-hand side, molecule D, is an amine. And amines are not generally acids unless they have a positive charge, making them more acidic. So this neutral amine is going to have a pKa around 40. So the smaller the pKa, the stronger the acid. So using the quantitative method, I know that this equilibrium goes to the right. If we think about using the qualitative method, so using the qualitative method is using CARIO, and we can kind of think about the bases now. So we're going to look at molecule B and molecule C. So in molecule B, we have a negative charge on a nitrogen, and in molecule C, we have the negative charge on a carbon atom, but very, very important here, we have resonance. So this is going to be kind of the key to sorting this question out. This is a difficult CARIO example because you have to remember that the resonance can play a big role in using CARIO. So if we look at the resonance contributor, we can see that we have this resonance contributor. So when you compare molecules using CARIO, you're going to want to compare them with the resonance contributor where the negative charge is on the most stable atom. Okay, so in this case, having that negative charge on an oxygen atom is what we're going to use to compare with our N- base on the left-hand side. So this is a example where some people might get tripped up because they might see that C- right here and think, okay, C- versus N-, the C- would be the stronger base. But the resonance switches us back to thinking about what atom is bearing the negative charge. And the more significant resonance contributor would have that negative charge on the oxygen. Right, so when we do that, it's N- versus O-. And O- is more stable because of electronegativity. The oxygen is more electronegative and it can better stabilize the negative charge. Okay, so that means that our stronger base is going to be the N- base. So I'll put strong base right here. And then weaker base. All right, and so using CARIO, we can say, all right, we know that CARIO always goes from strong base to weak base. Just like with pKa's, we're going strong acid to weak acid. So CARIO also supports this equilibrium going to the right. All right, now that we've kind of thought out the question, let's look at our answer choices. I always recommend kind of thinking out the problem first and then looking at the answer choices, because sometimes the answer choices are meant to kind of trip you up. So think about the question first, and then let's take a look at our answer choices. So answer choice 1, the equilibrium lies to the left. We know that that one is going to be false. Okay, actually, let me use a check mark because we're looking for false statements in this question. The equilibrium lies to the left. That is the false statement. So we're going to look for an answer choice that has a 1. We're going to cross off C, D, and E because none of them have a 1 present. Okay, the equilibrium lies to the right. That is a true statement. The strongest base is molecule C. Okay, molecule C is the one that we just determined was the weaker base. So that is a false statement. So 3 is also false. Okay, statement 4, the strongest acid is molecule A. And that is a true statement. Okay, so answer choice A is the correct answer for this question.